Hello friends, this video on DNF block elements part 26 is brought to you by examfear.com. No more fear from exam. On whatever we have studied about the D block elements 10. The first is the physical properties. We have seen that all these are metal, right? All are metal. They have high tensile strength, exception mercury. They are ductile, they are malleable, they have high thermal electrical conductivity, they have high metallic luster, they are all shiny, they have high melting and boiling point. This is something we have seen. Talk about the atomic size. The atomic size actually decrease as we go in the series, and if we go down the group, actually it increase, but due to lanthanide contraction we see that it is not followed from here to here, right? We have seen that. So there is a decrease in the atomic there is actually decrease in atomic size if you increase the atomic number in the same series, okay, and lanthanide contraction takes place here. We have seen that, okay, and lanthanide contraction we have a greater than expected decrease in size for elements from 57 to 71. From here lanthanum, there's a greater than expected decrease in size because of the f orbital, poor shielding effect. We have seen that. Talk about ionization enthalpy. Ionization enthalpy is nothing but the minimum amount of energy required to remove an electron to infinite distance from an atom in the gaseous state. This value increased from left to right, but there is some irregular trends also, and this ionization enthalpy actually depends on the effective nuclear charge, okay. Then we have the oxidation state. We have seen that it shows variable oxidation state. Example, manganese +2 and +7. In fact, it shows all these oxidation states, but the most prominent are +2 and +7. And also the number of oxidation states increase as we go in a series, and again it decreases, okay, because these are oxidation state depends on the presence of unpaired electron, and unpaired electron actually, if you see, this has 1, this has 2, it has 3, 4, 5, then 4, 3, 2, 1, 0. This is the number of unpaired electrons. So unpaired electron increase and then decrease. Thus, the number of oxidation states increase and then decrease. Then we have the standard electrode potential. We have seen that standard electrode potential actually becomes less negative as we go in a series, okay, and that is because of increase in the first and second ionization energy. But there is some irregularity here. We have seen that there is some irregularity here, okay. Then we have the stability or the solubility of higher oxidation state. So we have seen that the higher oxidation state you get typically when you form bond, the transition metal form bond with oxygen and fluorine. With oxygen and fluorine they get the higher oxidation state, and example is CrF6 MnO3F. In this case they have higher oxidation states. Why? Because oxygen and fluorine, because oxygen and fluorine has high electronegativity and small size. Thus, typically transition metals form higher oxidation state with these elements. If we talk about the chemical reactivity, we have seen that the metals in the lower oxidation state are basic. Chemical reactivity. So chemical reactivity, we talk about the oxide. We'll see that the metal oxides with lower oxidation state are basic. Why? Because in this case they have free electrons. All the d orbital electrons are not part in the bonding, and they have free electrons to donate. For example, MnO. Metals in the higher oxidation state are acidic. Please note, metals in the lower oxidation state are basic. Let me write here once again. Lower state is basic and higher state is acidic. Higher state is acidic because higher state all the electrons are almost used for bonding. So they accept electrons. For example, V2O5, Mn2O7, and this intermediate oxidation state are amphoteric. For example, MnO2, they are amphoteric. Okay. And if you talk about, they form bond with sulfide also, they form bond with halides also, but with sulfides and halides other than fluorides, they have low oxidation state. Then we have the magnetic properties. Magnetic properties, they are generally paramagnetic because of the presence of unpaired electron, and their magnetic moment is defined by mu is equal to n into n plus 2 bar magneton. There are some diamagnetic also. For example, zinc is diamagnetic, Cu plus is diamagnetic, but most of these are paramagnetic because of unpaired electron. They have a lot of colored ions, and these colored ions are also because of unpaired electrons. And unpaired electrons results in DD transition, and this DD transition is responsible for the color of this ions. Talk about the complex ions. They tend to bind with number of anions and ligands to give complex ions, right? These transition metals forms a lot of complex ions. Why? Because they are small in size. The metal ions are small in size and they have high ionic charge, and also they have vacant d orbitals to form bond. If we talk about the catalytic property, yes, they are known for this catalytic activity. Why? Primarily because they can adopt multiple oxidation state. They form various intermediate complex, and they also have partially filled d orbitals, which can easily provide space for adsorption of reactants and thus increase the rate of reaction. Then we talked about the interstitial compounds. Interstitial compounds are formed in small atoms like hydrogen, carbon, nitrogen. They are trapped inside the crystals of the metals, and they are typically non-stoichiometric. For example, as I told, TiH 1.7. But these interstitial compounds have different physical properties. They have high melting points and boiling points. Then they are pure metal. Then the next point we talked about is the alloy formation. These transition metal forms alloy. Why? Primarily for alloy formation, one atom will be replaced by another atom, and in transition metals we have a lot of atoms with similar size, and thus it forms a lot of alloys. Example is brass, copper and zinc. Brass is an alloy which is formed from copper and zinc. Bronze is an alloy which is formed from copper and tin. Okay, please note both the metal elements has to be a comparable size. If the comparable size of atom, then only it forms alloy. And this alloy has remarkably different properties. It has huge application in the industry. So these were the trend we have studied. If you have not understood, please watch this video again. Then you can get your concepts clear. With this, we'll start with the numerical. Thank you. Visit examfear.com to watch more videos, attempt free online tests, get free study materials, find tutors and mentors, and much more. Thanks once again.